All right, we're going to finish the review. This video is for problems 7, 18, 19, and 20. So we have 2 word problems, and then we have some examples of inverses. All right, so we're going to start with number 17. Sarah bought a rare grand piano for her house in 2005 for $25,000. It is estimated that the value will increase by 6% each year. All right, so increase means we're going to have 1 plus my r. 6%, remember we convert that to be 0.06, and that's going to be my r in my equation. $25,000 is our original value, so that's going to be my p. All right, so we're going to use the equation p, 1 plus r, and raise it to the value of t. Okay, that's what will be the amount of works of the piano. All right, so my function is a equals 25,000 times 1 plus the rate of 0.06 raised to the t, because I don't know how many years I've had the piano yet. All right, so part B, estimate the value of the piano in 2010 and 2022. So in 2010, I would have had the piano for 5 years, so t is going to equal 5. In 2022, I would have had the piano for, what is that going to be? 17 years. So t here is going to be 17. So first I'm going to plug in 5. So in the year 2010, my piano will be worth, let's see here. We're going to do 2,500, or 25,000, excuse me. 1 plus 0.06, raise it to the power of 5. The piano is going to be worth $33,455 and 64 cents. All right, and then in the year 2022, I'm going to bring my function back up, change my 5 to a 17, and that is going to be $67,319.32. All right. Part C, in what year would the value of the piano double and triple? So when it's doubling, I'm looking for the value of my piano to be $50,000 is what we're looking for. And to triple, we're looking for $75,000. So I'm going to use my table. Okay, remember it says in what year, so I need to actually add how many years it's going to take to my original year of 2005. All right, so I'm going to put my function into my y equals 25,000, 1 plus 0.06, raise it to the power of x, and I'm going to go to my table. All right, the first thing we're looking for is $50,000. How long will it take to double? Okay, so we're going to go down until we see that it is making, look right here, between year 11 and year 12, it's going to hit 50,000. It's barely over 50,000, but it already happened in year 11. Okay, so in the 11th year, it doubled, and that is going to be in the year 2016, because 11 plus 2005, so it is going to double in the year 2016. Because I had to add 2005 plus 11. All right, now for tripling, I see how long it takes for my the piano to get $75,000. So I'm going to scroll down until I see 75. Oop, there it is. Okay, it's already worth more than that at the beginning of year 19. So that means between the year 18 and 19 is when it was worth $75,000. Okay, so in the 18th year is when it tripled. So remember, I have to do 18 plus 2005, which is going to be the year 2023. All right, remember, it asked you in what year, so I have to say that it's in the year 2016 and in the year 2023. All right, let's go to number 18. We're going to invest $4,000 in an account that pays 4.8 annual interest, and it's being compounded weekly and monthly. So we're going to write those two equations for us. Remember here we're going to use the function where a equals our initial value times 1 plus my rate divided by n, which is how many times it's being compounded each year, raised to how many times per year, multiplied by how many years we have. So that's the equation we're going to use. All right, weekly. A is going to equal $4,000 times 1 plus my rate. Move this guy back 2 times. So we're going to have 0.048. All right, and we don't know how many years. If it's a weekly, there are 52 weeks in a year, so it's going to be compounded 52 times. So I'm going to say 52x. Monthly is going to be the exact same equation, except there are 12 months in the year. So instead of being divided by 52, we're going to be divided by 12. And we're going to raise it to the 12x. Okay. Those are our equations. Part B wants us to use those equations to figure out how much we're going to have after 7 years in both situations. So if I'm being compounded weekly, so this is the first one, I'm going to replace that x with a 7. All right, so I'm going to put a W for weekly. 4,000 times 1 plus 0.048 over 52 raised to 52 times 7, because this is our t now. Okay, that is going to give me 1 plus 0.048 by 52 raised to 52 times 7, 55, 96, 49. So I will have $5,596 and about 49 cents if it's being compounded weekly after 7 years. Right? If it's being compounded monthly, do that one over here. If it's being compounded monthly, take my 4,000, multiply it by 1 plus 0.048, divide it by 12, and raise it to 12 times those 7 years. And this time, so I'm going to bring my equation back up. My 52 is now 12. Not too much less, honestly. So we're looking at $5,593 and about 61 cents. So being compounded weekly only gives me what, $3 more after 7 years? So there's not really that much difference. All right, so that's all of the exponential stuff. Now the last two, 19 and 20, are about inverses. Remember, the main concept with inverses is switching your x and your y. Okay, so that is the big key. Switch x and y. Okay, when it comes to my graph, you need to remember that we are reflecting. Okay, all of my points on the graph reflect over the line of y equals x. Okay, so we're switching x and y, and in a graph that means we are actually reflecting every point over the line of y equals x. Okay, what is that line? That is the diagonal where it's 0, 0, right? See it? We have 0, 0, 1, 1, 2, 2, 3, 3. Okay, that is the line of y equals x. So I'm going to go ahead and draw that on here. Let's see, 10 and 10. I'm going to go ahead and draw this dotted line on both of my graphs. So there's it for here. I'm going to do it for my second graph as well. Okay, so there's my perfect diagonal lines. We're going to be reflecting over these lines. So we're going to graph a relation. We have a graph, we have a picture. I'm actually going to make a table and then put my points on there and then flip them and then graph those new points. Okay, So I'm going to call my first one f of x. That's my original function. Okay. Here's my x's and y's. We have 4 points. The coordinate point for this point is going to be -3 and +3. This point is at 0, 7. X is 0, y is 7. This one, my x is 3, my y is 4. And this last one, my x is 1 and my y is 2. All right, so here is a table of the picture that is already on the graph. Now, to find the inverse of this function, I'm going to flip all the x and y values. Okay, so now my new x and y values, okay, it was -3, +3, so now it's going to be +3, -3. We're going to switch them around. Same thing with my next point. Now it's going to be 7, 0. Okay. Then 4, 3, then 2, 1. Okay, I'm going to plot these new points, and I'm going to use a red pen to do it. Right, so these points are going to be in red, so you can see them nicely. +3, -3 is right here. Then we're going to have 7, 0. All right, 4, 3, and then 2, 1. I'm going to connect these guys. And you'll see, you can actually visually tell that this shape was reflected over that line, y equals x. If I were to fold my paper in half on that line, those two shapes would sit right on top of each other. All right, let's do the same thing. All right, so I'm going to create a table again. So the function that's already there, all right, this point is at -7 and -4. Our next point is at -1, +2. This looks like +3 and -2. And our last point is at 0 and then -9. All right, we're going to do the inverse, which means we're just going to take all of our points and flip them over. So now it's going to be -4 and -7, then 2, -1, -2, +3, and then -9 and 0. And I am going to graph this in red also. All right, -4, -7. It's okay that it's almost like inside the other piece. Once we're done, you're going to tell that it reflected over that line. 2, -1. Oh, that's not the right point. That's the right point. Ignore this one. It's wrong. All right, negative. Oh my gosh, it's all wrong. It's +2, -1. So actually I should go this way. -1 is right here. Here we go. -2, +3, and then -9, 0. I tried to do that right. -4, -7. Sorry guys, I messed this one up bad. Okay, -4, -7. There we go. I can graph. +2, -1. Got it. -2, +3. Okay, and then -9, 0. Goodness me. There it is. Okay, now let's connect these points. Sorry. All right, I connect these points and we can see that we have reflected over the line of y equals x. Now we're going to go to we need to explain what we did. Okay, so Well, as I was talking through, I want you to tell me, how did we graph those inverses? How did we look at the original? What did we do? And then how did we be able to create the shape of our inverse? So I'm going to leave this one up to you. This is a you answer question. I'm not going to give you that answer. All right. Number 20, we are finding the inverses of a bunch of functions. Okay, so remember, our main concept here is to switch x and y. So we are going to do that first. So part A, remember f of x is the same thing as y. So I'm going to switch these two to give me x equals 3y minus 9. Now I need to get this y by itself again. Okay, so I'm going to add 9 over to give me x plus 9 equals 3y. And then my last step is going to be divide each piece by 3. Okay, so when I do that, my y is now by itself, and we note that by saying y inverse is going to be equal to x over 3. That does not simplify. 9 over 3 does simplify to be positive 3. All right, and this is our equation. Remember, x over 3, this is the same thing as 1/3 x. So however you want to write it, it is the same thing. All right, part B, again, switch x and y. So we're going to make this x is equal to 1/5 times 3y minus 4. All right, first thing we need to do is we actually need to get rid of this fraction. We're going to multiply both sides by the reciprocal, which is 5 over 1. Doing that will eliminate the fraction. So 5x equals 3y minus 4. Now let's add that 4 over. And then we will finish by dividing each thing by 3. All right, so our y inverse function here is going to be equal to 5x over 3 does not simplify, and neither does 4/3. So there it is. You could also write it, since neither one of these simplified, you could have also kept it as 5x plus 4 over 3. These are the same answers. So whichever one you want to do. Okay. 2 more, guys, and we're almost done. Here we go, part C. This is going to be x equals 6y minus 18. I've switched them. Now let's get y by itself. Add 18 over. And now let's divide each piece by 6. So we're going to get our y inverse is equal to x over 6. Remember, that is the same thing as if you said 1/6x. So same thing here. And then we're going to add 18 over 6 is 3. All right, and D, last one. Let's switch our x and y. So x is equal to 1/7 to y plus 12. Remember, to undo a fraction, we multiply by the reciprocal. So we're going to multiply both sides here by 7. Eliminates the fraction. This gives me 7x is equal to 2y plus 12. Let's subtract 12 over. And then we need to divide each piece by 2. Giving me that y inverse is equal to 7x over 2 minus 6. Because negative 12 over 2 simplifies to negative 6. All right, and that's the only way to write it. All right, so this was all inverses, and then we had 2 word problems in the beginning. Remember, your test is Tuesday, January 23rd. If you have any questions, make sure you go and ask your teacher. All right, good luck.